Hello guys, I hope you are all doing well. Today I have brought a very interesting and challenging question from chapter 2 in 2022-2023 in the second attempt. Let's dive into the question with the full focus. Question 7 in 2022-2023. Look at the question. A question says a 10 kilogram mass is attached to a cord that's wrapped around the wheel. Okay, a 10 kilogram of mass attached to a cord string that is wrapped around a wheel. This is the wheel, okay, with the radius of 10 centimeter. The radius of the wheel is 10 centimeter, okay? The figure is given in this question. The acceleration of the mass that attached to the cord is in the frictionless incline is measured to be 2 meters per second square. The amount of the acceleration of this object when it is slides into this frictionless surface is 2 meters per second square, assuming that the axle of the wheel to be frictionless and determine the moment of inertia of the wheel. What is unknown? The moment of inertia of the wheel. Guys, this mass, this 10 kilogram is not the mass of the wheel. Sometimes the students are confusing with this mass, so they are using the equation of the moment of inertia of the wheel, which is equal to 1/2 mr square. So they place the mass into the equation of the moment of inertia. So this is completely wrong. Okay, don't make this mistake. Be careful. So this is the mass of the object. To determine the moment of inertia, we have to use the Newton's second law for rotational motion. How? Look. Listen carefully. To determine the moment of inertia of the wheel, you have to use the Newton's second law for rotational motion. Torque is equal to I alpha. Alpha is equal to what? Torque divided, moment of inertia is equal to what? Torque divided by alpha. By using this equation, you can determine the amount of the moment of inertia for the wheel. First of all, you have to draw the figure, and already the figure is given. Okay, we have a wheel and a mass. So this is the wheel, and this is the mass of the object that attaches to the cord of the wheel. Okay. The force of the cord and the force of the cable that exerted on the wheel provides and creating a torque on the wheel. Why? Because torque requires what? Force and the distance from the axis of rotation. The radius of the wheel is given is 10 centimeter. The radius of the wheel is 10 centimeter, which is equal to 0.1 meter. And the mass of the object is 12 kilogram. What is this? This is the mass of the object. 12 kilogram is moving downward from this frictionless surface, this frictionless incline. The angle of the incline is 37 degrees. Okay. And the acceleration, and the object is moving and slides down with the acceleration of 2 meters per second square. The amount of the acceleration for this wheel is 2 meters per second square. This is the tangential acceleration and the linear acceleration of the object. Guys, look. For the inclined surface, the object is moving downward without any applied force. And the force of the cord resists the movement of the object to slides down the incline. And so we have to analyze the forces that acting on the object from this incline. If you remember in grade 11, you studied the force that acting on the object when it's moving down from an incline. As usual, the gravitational force is directed downward toward the center of Earth, and the normal force is perpendicular to the surface of the object. Because we have incline, of course, this gravitational force will be resolved into two components. Into how many components? Two components. Why? Because we have incline, the surface incline, not horizontal. This gravitational force can be resolved into two components. Look, x component, fgx, and y component, fgy. And the angle of the incline always with the fgy. The angle always in the incline between fgy and fg. The angle here is 37, and also here is this 37. Because the angle with y component, so that is why we have to use cosine. According to Pythagorean theorem, fg cosine theta for the y component. and FG sine theta for the x component. Is it clear? Now, how can you determine the moment of inertia of the wheel? The moment of inertia of the wheel is unknown. We cannot use 1/2 mr squared. Why? Because we don't have mass. This 10 kilogram is not the mass of the wheel. This is the mass of the object that attaches to the cord and slides down from the incline. Guys, look. So you have to make your plan to solving this question. Our plan is Newton's second law for rotational motion. Torque is equal to what? I alpha. How about I is equal to torque divided by alpha? Okay. Now, do we have torque? The amount of the torque that exerts the wheel, we don't have. How can you determine the amount of the torque? Torque is equal to what? Is equal to F, which force? The tension force of the cord, times the radius of the wheel. Do we have tension force? Of course we don't have. We don't have tension force. How can you determine the torque without tension force? We cannot. So in this case, before solving the question and before finding the moment of inertia, we have to find out the tension force that exerting on the edge of the radius to determine the amount of the torque. Guys, according to Newton's second law, net force is equal to what? Net force is equal to mass times acceleration. Guys, the tension force is located on the x-axis or y-axis. Of course, is located on the x-axis. Okay, so the summation of the force on the y-axis is equal to 0. Fn is equal to Fgy. And the summation of Fy is equal to 0. All force on the y-axis is equal to 0. Why? Because the object is not moving up and down. The object slides down from the incline. So that is why we have to count only the forces that acting on the x-axis. How many forces do we have on the x-axis? Absolutely, we have two forces, Ft and Fg sine theta. These two forces in the same direction or opposite direction? Of course, these two forces are in opposite direction. So that is why we have to subtract them. It's going to be Fg sine theta minus Ft equal to Ma. Guys, listen carefully. Look. Replace Fg. We don't have Fg, but we have mass and gravity. Mass 10 kilogram times 9.81 times sine what? 37. Minus Ft, unknown, is equal to mass 10 kilogram times acceleration 2. 10 times 9.81 times sine 37. By calculator, you can calculate 9.81 times sine 37. I got 59. Okay? 59 minus Ft is equal to 20. Ft is equal to what? 59 minus 20 is equal to 39. Okay, 39.04 Newton. So this is the tension force that acting on the edge of the wheel. Now we can substitute into this equation. Torque is equal to what? Ft times R. Do we have Ft? We didn't have, but we found 39.04. And do we have alpha? No, but we have 80 over R is equal to 2 over 0.1. Alpha is equal to 20 rad per second square. Why? Because to determine the moment of inertia, we need both the amount of net torque and the angular acceleration. Okay, angular acceleration. I found both of them. Now replace into this equation. I is equal to torque over alpha. We didn't have torque, but we found 39.04 divided by 20. Okay, guys, look. Sorry, torque is equal to. Sorry, guys, I do apologize. Torque is equal to what? I forgot to multiply with the radius. Torque is equal to Ft 39.04 times 0.1, guys, because the amount of the force that exerting on the edge of the wheel is a rigid body that acting with the radius of the wheel, it becomes the distance from the axis of rotation to the edge of the wheel, which is the radius of the wheel. To determine the amount of the torque, we have to use this equation, Ft times R, and the angle between Ft and R is perpendicular. Sine 90 is 1. FT 39.04 times 0.1. I got 3.904 Newton meter. Now, alpha is equal to what? Alpha is equal to AT over R. 82 over 0.1, 20 rad per second square. Why? Because to determine moment of inertia, we need both tension, the torque and alpha. We found both of them. Now replace into this equation. I is equal to torque over alpha. Torque I found 3.904 divided by alpha 20 is equal to divided by 20. I got 0.19 kilogram meter square. Which one is correct? A 0.19 kilogram meter square is the correct answer. Thank you for listening. I hope you get benefit from this question.